Kahan, and we're going to talk about slope. Now, we've been talking about parallel and perpendicular lines, and what we're going to talk about now is relating that back to algebra. Remember, in algebra, we had lines that were on a graph. So what we're going to look at is what happens when I have parallel and perpendicular lines on graphs, on coordinate planes. So let's review a little bit what we remember about Algebra 1. Slope is the same thing as rate of change. We also counted slope by counting the rise over run. And remember that number that we counted, rise over run, describes how steep that line is. And we can have different kinds of slopes. In this first picture right here, you see the line going uphill. Remember that is a positive slope. And if the line was going downhill, that was always a negative slope. We also had lines that were horizontal. And remember, horizontal lines have a slope of 0. Imagine walking along and you're not going uphill or downhill at all. You're just walking straight across a flat plane, so 0. And those equations, remember, just look like y equals some number. An undefined slope, or when we had vertical lines. So imagine, remember, if you can imagine going up a cliff, you would need some climbing gear to walk up that straight line. So that's an undefined slope. It's a vertical line. And those equations always look like x equals some number. So when we have parallel lines on a coordinate plane, they have to have the same slope, because parallel lines are going in the same direction. They never intersect. So they need to have the same slope. For example, if this slope was 2 over 1, then this slope would have to be 2 over 1. But when we have perpendicular lines, those do intersect, and they intersect specifically at a 90-degree angle. So we want one to be going in a positive direction, one to be going in a negative direction. So because of that, perpendicular lines, their slopes are what we call opposite reciprocals. So opposite meaning one is positive and one is negative. Okay, so one of the slopes is positive, one of the slopes is negative. Reciprocal means that the rise over run is flipped upside down. So that fraction gets flipped around. So for example, if this red line had a slope of 2/3, then this perpendicular blue line would have to have a negative slope, and that fraction would have to be flipped around. So it would have a slope of -3/2. So notice that this one's positive, this one's negative, and those fractions are flipped upside down from each other. Another example would be, let's say I had this blue line was -4. Okay, so that slope had a -4 over 1. Now, something that you may not remember right away is if I have just a whole number for my slope, that's understood to be divided by 1. So my rise is -4, so I'd be going down 4 and to the right 1. So that's why when I do the reciprocal of 4 over 1, when I flip that fraction around, I'm going to get 1/4. And again, notice that I originally had 4 was negative, so this opposite reciprocal has to be a positive 1/4. So that would mean that the red line would be a positive 1/4. So that's something that you need to remember when we are looking at parallel and perpendicular lines, is that parallel lines have the same slope, and perpendicular lines have opposite reciprocals. Flip the fraction around and change the sign. So let's look at an example. So in this example, we're going to state whether the line that we have here is parallel or perpendicular to this line. So first we got to figure out is what is the slope of this line that goes through these points. Now, we don't have a graph, and you could graph these and then count the rise over run, but I don't want to always have to get graph paper out. So something you might remember from algebra is your slope formula, and I'll remind you here. So the slope formula is when we take y2 minus y1 and divide it by x2 minus x1. And when I say y2 and y1 and x1 and x2, what I'm talking about are these coordinates. So this would be x1, this would be y1, and then this would be x2, and this would be y2. So it's just the x and y coordinates of the first point and the x and y coordinates of the second point. So if I plug that into those formulas, then I'm going to have y2 is going to be -2, and then I'm going to subtract my y1, which is 1, so I'm going to have -2 minus 1, and I'm dividing that by my x2 minus x1, so x2 is 4, and I'm subtracting a -3. Now careful here, I put a plus here, but if I do minus a -3, that's the same as doing plus 3. So that's why I have 4 plus 3. So -2 minus 1 is -3. 4 plus 3 is 7. So my slope here of these 2 points is -3/7. So if you were to graph that, you would also get that as your rise over run. Now, if you're not big on formulas, I want to remind you of another way you can do your slope is if you remember from tables, when you did tables in Algebra 1, we would look at, I can stack these points one right underneath each other. And remember that this column right here, these two are my x's, these are my y's. And all I have to do is say, okay, how much did this change from here to here? If I went from +1 to -2, that went down by 3. And then if I went over here on the x's from -3 to 4, then I went up by 7. So again, this is really like a algebraic way of calculating my rise over run. So my slope has to be the rise, the y parts, which was -3, divided by my run part, that was the 7. And notice that we get the same exact answer here as when we did the formula. So I don't care which way you do it, I just want you to always do it correctly. So this is the line that we're going to compare these two lines to. So this is kind of our standard for comparing everything else. So we're going to compare these slopes to -3/7. So if I'm trying to find the slope of this line, I can either do the formula, remember the y2 minus y1. So if I do that, I'm going to have 4 minus a -3. Remember, that's going to give me 4 plus 3, which is 7. And then I'm going to have 0 minus a -3, so that's 0 plus 3. That gives me 3. So this is going to give me a slope of 7/3. And again, you could do that same thing by stacking your numbers. And if I could say, okay, how do I get from -3 to 4? That goes up 7. So that's a positive 7. How do I get from -3 to 0? That goes up 3. And so my slope is my rise over run, my 7 divided by 3. Okay, and I'm getting the same exact answer. So now I need to compare. I need to say, well, 7/3, how does that compare to -3/7? Well, 7/3 is flipped around from 3/7, so that's a reciprocal, and it's the opposite sign. So I could say that this line is perpendicular to that original line because they are opposite reciprocals, their slopes are. Now let's do line 2. We're going to do the same thing. I can either do the formula where I'm doing y2 minus y1, so that's 5 minus 2. And then my x2 minus x1, 3 minus 10. So 5 minus 2 gives me 3, and 3 minus 10 gives me -7. So I'm getting an answer of -3/7. And again, just in case you want to see this one more time, I would do, get from 2 to 5, that's adding 3. And to get from 10 to 3, that's subtracting 7. So that slope would be my rise over run. My rise is 3. My run is -7. Now remember, with negative slopes, it doesn't matter if the negative goes in the numerator, the denominator, or out in front. They all mean the same thing. So whether I put the -7 down, or the negative down here with the 7, or the negative here with the 3, it means the same thing. So now we got to compare. We know what our slope is. Now we got to compare to our original. Negative 3/7, how does that compare to the original? Well, they're the same. So that must mean that this second line is parallel to that original.